guys. In this video we will be looking at mathematics paper 2, vectors, specifically question 3 from 2022 GCE and internal. So in this part here, I just want to show you how to prove the collinear, okay, or how to show the points if they are collinear. So I'll start with 2022 paper 2 GCE. So the question is, the position vectors of the points A, B and C are -1 by -2, 3 by 6 and 9 by 18 respectively. So like on this point here, they have used the word respectively. So we are going to take the points according to the way they have arranged them. So as for vector A is going to be -1 by -2, like this, okay, comma. Then as for vector B is going to be 3 by 6, like this one here. Then the last one, which is C, is going to be 9 by 18, like this. Now the question is saying, show that the point A, B, and C are collinear. Okay. So now for us to prove the collinear here, to prove if these points are collinear, of course they are collinear now, we need to prove it. Okay, so I'm just going to give you a simple formula which is going to help us to answer this part here. So here I'm going to say, let's say for example, if I have A as vector A, I'm going to say A minus B. So of course here I'm going to introduce the open bracket and also here close bracket is equal to A minus C, open and close. So what I mean here is like this. Since here we have three vectors, since here we have three column vectors, we have A, B, and C. That is the reason why I'm saying A minus B and A minus C. Now, hear me clearly here. This A here is subtracting both B and C. So here I'm going to say A minus B is equal to A minus C, like this. Okay. So now, since these are column vectors and vector A, it is this one here. So I'm going to say this one here is going to represent vector A, which is this one here. Then as for this one here, it is going to represent small letter what? B, like this one here. Then the last one, which is C, it is going to represent the small letter what? C, like this one here. Now since here we want to prove for collinear, so what I'm going to do here, I'm going to put a variable at this point here or at this point here. Okay, so let me just do this. Since I know that this A here, it is representing this vector here, which is -1 by -2, like this one here. Then remember here we have a minus, so I'm going to say minus. If you want here, you can introduce the square brackets like this, okay. Then here I'm going to say open bracket. What is my vector B? My vector B is this one here, which is 3 by 6, close square bracket, is equal to, now here I'm saying, for us to prove that this side here and this one here, they are collinear, I need to introduce a variable at one side, either at this point here or at this side here or on this side here. Okay, so let me just introduce the variable which is K on this side here. So I'm going to say K, open bracket, or square, open bracket, then open bracket. So this one here, vector A, it is this one which is -1 by -2, close, minus. Then as for vector C, which is this one here, vector C, this one, I'm going to say open bracket, 9 by 18, then close square brackets. Okay. Then from there I'm going to say -1 minus 3 I'm going to get negative 4, like this one. Then this one here, I'm going to say negative 2 minus 6. Here I'm doing like this, negative 1 minus 3. So here I'm going to get 4, which is this one here, by negative 2 minus 6, I'm going to get negative 8. So I'm going to say open bracket, then close, is equal to the first variable, which is k. I'm going to write the variable, which is k here. Then I'm going to do the same. I'm going to say negative 1 minus 9, I'm going to get negative 10. Then negative 2 minus negative 18, I'm going to get negative what? 20. Okay. Then from there, now, since this one here, it is a scalar, so it is going to multiply with everything inside the what? The brackets. Okay, so I'm going to say negative 4 by negative 8 is equal to k multiplied by negative 10. I'm going to get negative 10k. Then k multiplied by negative 20. I'm going to get negative 20k close. Now, as for this one here, as you can see, the things on top here, they are going to balance. What I mean here is like this. So this negative 4 is going to go with negative 10k. So I'm going to say negative 4 is going to go with negative 10k. Or negative 8 is going to go with negative 20k. Okay. So let's move on. Now, since here there is a variable, and we are looking for the value of k here, I'm going to say divide by negative 10. Even here, divide by negative 10. So this 10, negative 10, and this one here, they are going to cancel each other. So here we are going to remain with k. This negative and this one here, they are going to cancel each other. Then from there now I'm going to say 2 into 4, I'm going to get 2. Then 2 into 10, I'm going to get 5. So here I'm going to say 2 over 5. So this one here is my first value. Okay. Then my next value is going to be, since here I'm looking for the value of k, I'm going to divide by negative 20. Divide by negative 20. So negative 20 and negative 20, they are going to cancel each other. Then here I'm going to remain with k. So I'm going to say k is equal to negative and negative, they are going to cancel each other. Okay. So here I'm going to say 4 into 8, I'm going to get 2. Then 4 into 20, I'm going to get what? 5, which is this, 5, which is this one here. So now, as you can see here, when proving the collinear, when proving the points for collinear, you need to make sure that the values that you get here are the same. Okay, so now as you can see here, the value of k is 2 over 5. Even here, the value of k, it is 2 over 5. Okay, so this one was carrying 5 marks, which means on this part here, you can get 5 marks. So remember to use this one here. This one is very simple. So on the next part, I'm going also to use the same one here. Okay. Now it will be different because of the diagram. So let's move on. 2022, paper 2 internal. Okay. So the question is here saying, in the parallelogram OABC, OA is equal to 4a vector, and a vector is represented by a bar. Okay. OC is equal to 6c vector. AP is equal to 2 over 3 AC vector. So on this point here, let's say for example, if we find AC, it will be very easy for us to find AP here. So it is very, very important for us to understand the statement here. Okay, and M is the midpoint of BC. So they are saying M is the midpoint of BC. So the ratio from the ratio or the vector from this point here up to this point here is equal to the vector from M up to C. Okay. So now, since this one here, it is a parallelogram. Now, the special thing here about a parallelogram here is that parallel lines, they have same vectors like this. Okay. So if this one here, it is to a vector, even this one here, it is going to be 2 vector. Okay, if the direction is showing like this, even this one is going to show like this. Okay, but in some instances they are going to do like this. Okay, let's for example, if they draw the line like this, another one like this, then they say the direction is going downward. Then as for this one here, the direction is going upward. Then the vector here is 2a vector. Then as for this one here, it's not going to be 2a vector, but it is going to be negative 2a vector. Okay, yeah. Now let's try to answer some questions. Okay. So the first question here is saying, find in terms of a vector and or c vector. A, we are finding AC. Now what we need to understand here is that since here we are finding AC, let me do like this. Since here we are finding AC, so I'm going to write AC. So now when finding AC vector here, A is going to be our starting point. Okay. Then C is going to be our ending point. Okay. So we can see like this. This one is our A, and then this one is our C. Now, when finding AC here, you need to choose roots which have vectors. You need to choose roots which have vectors. Apart from that one, you need also to consider the arrows. Let's say, for example, as for this one here, since I've been given OA, but I don't have AO. As you can see, if you come from A going at point O, you don't have AO, but you only have OA. So for you to find AO, since you know that the direction is going upward, then as for us, we are going downward. For us to find AO, we need to put a negative sign here on the A vector. Okay, so the first thing here, I'm going to write the directions or the routes that I'm going to take. So from A, I'm going to go to O plus, then from O, I'm going to reach what? C. So here I'm going to say AC vector is equal to, what is my AO vector? Like the way I was saying, we are coming from O, going, we are coming from A going to point O. So which means, as you can see, the way the direction is here, we are going downward. We are going oppositely to the direction. So we are going to put a negative. So I'm going to say negative 4a vector. So don't forget to put a bar here. Okay. Then here I'm going to say plus. What is my OC? My OC here it is a 6c vector. Now as you can see the way the directions are, we are going where the direction is going, right? So which means on this part here, the value of OC is going to be a positive, like 6c vector. Okay, so here, let's rearrange the numbers by starting with the positive value, which is 6c vector minus 4a vector. As for the first one, we are done, which is question A. Then question B is saying OP. Like the way I was saying, this one here is our starting point. This one here is our ending point. So we need to choose roots which are vectors. Now, for us to reach point P here, we need to use the root like OA and AP. So I'm going to say, since O is my starting point, I'm going to say OA. Then from A, I'm going to go at point P. So now, as you can see on this part here, do we have OA? Of course, here, OA we have. Now, what about AP? AP we don't have, but it is very easy for us to find the AP. Like they were saying here in the statement here, they were saying AP is equal to 2 over 3 of AC. And we have already calculated the AC, which is this one here, on this part here. So, if we want to find AP here, we are going to replace AC vector with the values that we have found here. So, I'm going to say AP vector is equal to 2 over 3, open bracket, and then here I'm going to say 6c vector minus 4a vector, right, this one. Okay, so here I'm going to say 2 multiplied by 6, I'm going to get 12. 12 divided by 3, I'm going to get 4. Remember, this one here, it has a c vector, so I'm going to say c vector. Okay, then here I'm going to say 2 multiplied by negative 4, I'm going to get negative 8 over 3. Now, as for vectors, they exist independently. So I'm going to say a vector. Don't put your vector on top here. Okay. So this one here is going to be my AP. Okay. So here I'm going to say AP is equal to, what is our OA? Our OA here, it is what? 4a vector. So I'm going to say 4a vector plus, what is our AP? Our AP is this one. Yes, so I'm going to say, since I know that negative 8 over 3, a vector, they are like terms to 4a vector. So here I'm going to say 4 or plus 4 c vector minus 8 over 3 a vector. Now, like they were saying, these two are like terms. So I'm going to say 4a vector minus. So don't change the sign here, because on this part here or on this side here, we don't have an equal sign. Okay, but we have an equal sign on this part here. So I'm going to say negative or minus 8 over 3 a vector plus 4 c vector, which is this one here. Okay, so here I'm going to say 3 multiplied by 4, I'm going to get 12. 12 minus 8, I'm going to get 4. So 4 over 3 a vector plus 4c vector. Okay, so on this part here, I'm going to say, what I mean here is like this. We have this number here, like this one here. So here I'm going to find the common denominator, which is 3. Then here I can balance it by by 1. Okay. So I'm going to say 1 into 3, I'm going to get 3. 3 multiplied by 4, I'm going to get 12 here, a vector. Then here I'm going to say 3 into 3, I'm going to get 1. 1 multiplied by negative 8, a vector, I'm going to get negative 8a vector. Now, as you can see, these two are right terms. So I'm going to say positive 12a vector minus 8a vector. I'm going to get 4a vector over 3. Now, here I was saying, vectors, they exist independently. So I'm going to write it like this. 4 over 3a vector. Like this one here. Okay. So let's move on. Now, as you can see here, the number which is common here, it is 4. Apart from 4, we can say 3. Okay, I'm going to do like this. So I can say 4 is common. I'm going to factorize 4. Okay, out. I'll factor 4 out because I know that 4 is common here. Then here I'm going to say open bracket. 1 over 3 a vector plus c vector. So this one, we are done. Okay, so remember this one here, it is our OP, a vector. Okay, let's move on to the next one. Okay, the next one is saying we need to find OM. Okay, we need to find OM. So now, for us to reach point ME, we are coming from O, then we are going to end at point M. So I'm going to say O is our starting point, then M is our ending point. So I'm going to say when we move from O, we are going to go at point C. So O, C vector plus C, M, like this. Okay, now as you can see, in the statement here, they have mentioned that this one here is a parallelogram. And parallel lines, they have same vectors. So this line here is parallel to this one here. So if this one here is for a vector, even this one here is going to be for a vector. Even this one, OC, is parallel to AB. Okay, so these two, they have same vectors. So here I can say this one here is also 6C vector. Now as you can see here, in the statement they were saying, M is the midpoint of BC. So our M here is the midpoint of BC. Now since M is the midpoint of BC and the distance or the vector from M up to C is equal to the vector from M up to B. So for us to find MC here, I'm going to divide by 2. Since I have two things here, so I'm going to say 2 into 4, I'm going to get 2A vector. So which means from M up to C, I'm going to have 2A vector. Even on this point here, from B up to M, I'm going to have 2A vector. Okay, now let's try to answer this one. Do we have OC? Yes, of course we have OC here, which is 6C vector. And be mindful of the direction. We are going where the direction is going. So the value is going to be a positive 1. So it is 6C vector plus. As for this one, like they were saying, parallel lines, they have same vectors. Now this arrow here is showing that it is going on top. Even this one here is going where? On top. Okay. So this one here is going to be plus 2A vector for CM. Okay. As for OM, we are done on this part here. Okay. Let's look at the last one, which is saying, hence or otherwise, show that the points O, P, and M are collinear. So I'm going to use the same formula that I showed you on the first question. Okay. So on this part now, since here they are saying O, P, and M. So I'm going to say, now on this part here, since this one is the diagram, we don't have column vectors. So instead of saying A minus C is equal to, let me say A minus B is equal to A minus C, I'm going to say AB is equal to AC. Okay. The reason why I'm saying AB is equal to AC, because here we don't have column vectors. But on the first one here, on the first question there, we are D column vectors. Okay. So now on this part here, since I'm saying AB is equal to AC, then here I've been given O, comma P and M. So this O here is going to be my A. Then this P here is going to be my B. Then this M here is going to be my C. So I'm going to write, what is my A here? My A here, it is O. Then what is my B? My B here, it is P. So this one here is going to be OP vector is equal to, what is my A here? My A here, it is O. Then what is my C here? My C here, it is what? M vector. Now like they were saying here, for you to prove that this side is collinear to this side here, you need to introduce the what? The scalar, which is the variable. So, as you can see, we have already found the OP, which is this one here. OP is equal to 4 over 3 A vector plus 4 a C vector. So here I'm going to say 4 over 3 A vector plus 4C vector is equal to, now here I was saying you need to introduce the scalar, which is K. So I'm going to say K, open bracket. Then here I'm going to say, what is my OM? Our OM here, it is a 6C vector plus 2A vector. So I'm going to say 6C vector plus 2A vector. Now since this one here, it is a scalar, so it is going to multiply with everything inside the what? The brackets. Okay. So here I'm going to say 4 over 3 A vector plus C, 4C vector is equal to K multiplied by 6C vector. The answer is going to be 6K C vector. Okay, so the variable should come first, then at the end you put the vector. So similar to this one here, I'm going to say plus a k multiplied by 2a vector, I'm going to say 2k a vector. Now as you can see here we are having a, even here we are having a. Here we are having c vector, even here we are having c vector, here a vector, here a vector. So I'm going to say this one here is going to go with this one, even this one here is going to go with this one here. So I'm going to say 4c vector is equal to 6k c vector. Now I'm looking for the value of k. So here I'm going to divide by 6c vector, even here by 6c vector. So 6c vector is going to cancel with 6c vector. So here I'm going to remain with k. So here I'm going to say k is equal to, so c vector and c vector, they are going to cancel each other. Then here I'm going to say 2 into 4, I'm going to get 2. Then 2 into 6, I'm going to get 3. So my answer here is going to be 2 over 3. The last one. Or I'm going to say 4 over 3. A vector is equal to 2ka vector. Now since here I'm looking for the value of k, I'm going to divide by 2a vector. Even here I'm going to divide by 2a vector. So these two things, they are going to cancel each other. So here I'm going to remain with k. So my k is going to be 4 over 3a vector divided by 2a vector. Now let's imagine if here we are having 1, 2 divided by 1. So now what usually happens here to division is like this. Division changes to multiplication, and once it changes to multiplication, the numbers, they are going to reciprocate each other. So here I'm going to say k is equal to 4 over 3a vector multiplied by 1 over 2a vector. So the number at the bottom will go on top, and then the number on top will go at the bottom. The numerator becomes the denominator, and the denominator becomes the numerator. Okay. Now as you can see here, I can see like this. This one here, it is a vector, like this one here. So this a here and this one here, they are going to cancel each other. Then here I'm going to say 2 into 2, I'm going to get 1. 2 into 4, I'm going to get 2. So my value for k here is going to be 2 over 3. Now, like I was saying, the answer z should be the same. So the value of k here, it is 2 over 3. Even here, the value of k, it is z, 2 over 3. So thanks for watching. See you next time. Remember to like the video and subscribe to my YouTube channel. Thank you very much.